All right, our objective for this lesson is to review number 4 and number 3. The list below shows the number of miles Lance ran North Park Mile on each of 6 consecutive days. What is the median number of miles? What's median? Who can tell me? Real quick. Sarah. Good. Circle median. Median is the middlemost number. Okay, Mitch, to find median, what should we do to the data? Good. Put it in order. So 2, cross it off. 4, cross it off. 6, 7, 8, 10, and 11. Okay, so if they ask you to find median, first thing that should come to mind is put them in order, find the middlemost number. Jordan, what are the middlemost numbers here? Good. Are there one of them or 2 of them? Good. There's 2 middlemost numbers because there's an even set of data points. Willow, if there's 2 numbers in the middle, what do we do? Good. So add them, divide by 2. So 7 plus 7 is 14, divided by 2. So the median is 7. We all have that one? All right. Number 2. What do you think about when you first see number 2? What's the first thing that comes to your mind? Third period expressed this. Connor? A lot of words. What else comes to mind when you see number 2? Say that again, that you're going to guess. Okay. What else? I want to hear. Bray? Don't read it. Oh, don't say that. Corey? Okay. So here's what I want to tell you. If they give you a huge annoying problem like this, that probably means that it's really easy. They want you to look at it and kind of freak out and say, I can't do this, it's too long. Don't think that, okay? Let me quickly read through it, and I think you guys will remember what I had you do on this problem, because I taught you this section a couple months ago. Okay, so it says, a student research team is investigating whether the size of adult grasshoppers in the grass has changed over time. Kind of bizarre. The lengths in centimeters of 56 grasshoppers the team recently collected from the field, it should say field, not ocean. Grasshoppers don't live in the ocean. At least I don't think so. Are recorded in a box and whisker plot. One of the grasshoppers will be randomly selected from the 56 grasshoppers for a collection of genetic material for a future student. What is the probability the length of each grasshopper will be greater than the lower quartile of the lengths recorded in the box and whisker plot? Anyone remember why I flew through that? There's a reason. Gray, why did I fly through that? Because it's easy. Why is it easy? Tell me why. Okay, good. You just told me a lot. Okay, why else though? Do you guys remember when I taught you this? I don't remember how long ago. What did I have you do on this problem? Cody? Yeah, but we're not there yet. Just something more basic. Mitch? Yep, but even more simple than that. I'm surprised you guys don't remember. Olivia? Awesome. Cross off all this junk. You don't need that. Okay? Yeah, we're going to call it junk because they're trying to confuse you. They're trying to trick you. You don't need any of that. All you need to know is that they're asking you, what's the probability that the length is going to be greater than the lower quartile? You don't need all that stuff about grasshoppers in a field and research, right? We don't care about that. They're asking us about the box and whisker plot. All you need to know are the parts of a box and whisker plot. So can you guys yell out, what is this? Lower what? Not lower quartile. Lower extreme. What's this? There we go. Lower quartile. What's this? Median. Don't say middle. Median. Same thing, but what's this? Good. Upper quartile. What's this? Good. You have to know what all these are. You also have to know, Bray, what % of the data is here? Good. Tony, what % of the data is here? Heather, what part of the data is here? Good. Jenna, what % of the data is here? Good. We need to find the probability that the grasshopper is greater than the lower quartile. And I could try to draw a grasshopper, but that would not be such a good idea. There's our grasshopper. Horrible. What's the probability that the grasshopper is going to be greater than the lower quartile? And don't complicate it. Mitch? Lower quartile. greater than the lower quartile. Greater. You're thinking the opposite. You know what I mean? Greater. So here's our grasshopper floating around right here. The probability the grasshopper is greater than the lower quartile is 75%. 25, 25, 25. Now, Mitch would be right if they said, what's the probability that the grasshopper will be lower than the lower quartile? Then it would be 25%. Remember, the numbers are bigger this way. This is the upper extreme. Smaller this way. That's the lower extreme. You okay with that? Cody? You could, but they're asking us what's the probability. So you just want to give a percentage. More than likely, this will be multiple choice. Okay? Anyone else? If you're not with me, please say something. Luke, you okay? Okay. All right. Next one, number 3. All right. The list below shows the number of miles Horace ran North Park Lake on each of 5 consecutive days. How far does he have to run on the 6th day?
Get rid of the fraction, multiply by the bottom number. Get 37 plus x equals 42. Heather, who told me? Bray, how did Bray get 5? What's the next step? Say it again. Nope, not add. How do you get 37 to the other side? It's already positive. It's the opposite of adding. Minus it. Olivia, what do we get? Good. 5 miles. What does that mean? The answer is 5 miles, but what does that mean in the problem? Connor? Good. He has to run 5 miles on the 6th day to have an average of 7. Rachel? Go ahead. Uh-huh. 37 divided by 7 is not 6. But 37 divided by 7 is not 5. Like, I think what you're telling me, Rachel, is when you... Oh, you're rounding it. Yeah. Gotcha. I don't know if that always works, but it might. I'll have to check. Just because you're rounding, you know what I mean? Or do you always do it that way? Okay, then keep doing it that way. If it works for you, always do it that way. Any other questions or comments of how to do an average problem? Okay. No.
I know you kind of like use your head, like you mentally do some of it. Yeah, sure. Anyone else? All right, let's go to number 4. Number 4, Georgia's score on a math test is equal to the median value of all scores on a test. Based on this information, what can you say about Georgia's score when compared to the other class? When you see median or anything about a box and whisker plot, draw a box and whisker plot. Okay, this is George. Okay, George is in the middle. He's equal to the median. What can you say about George's score on the test? So this would be either open-ended or multiple choice. George's score is equal to the median. What can we say, Amanda, about George's score? Okay, so one thing we could say is George scored better than 50% of the class. What else could we say? That's one thing. George scored better than 50% of the class. What else could we kind of like analyze this as? Rachel, what else? Good. You could also say 50% of the class did better than George. You could phrase that same sentence as George did worse than 50% of the class. Okay, he scored the same as the median. What does it mean? Okay, yes, there's 2 different ways to say it. If it's open-ended, they will grade it accordingly. If it's multiple choice, just one of those would be part of the multiple choice. There would not be both of those on there. Are you okay? Okay. You guys with me on that one? You guys tired today? You guys look so tired. Or hungry. Okay. I just ate lunch, so I'm energized now. Okay, number 5. This one's kind of weird too. The range of weights in pounds of all cows on a farm is 330 pounds. What can you say about the weight of the cows on the farm? Raise your hand if you know this one. The range of weights of cows on a farm is 330 pounds. What can you say about the weight of the cows? Tony, what do you think? Good. There is at least, let me actually write that better, differently. There is at least one cow on the farm. I like that, Tony. Good. One cow on the farm that weighs 330 pounds more than another. Basically, all they're asking you is to apply this to the definition of range. Range is the largest number minus the smallest number. So you're taking the largest weight of a cow minus the smallest weight of a cow. There's at least one cow that's 330 pounds more than another one. That's probably a pretty big cow. That, again, could be multiple choice. If so, find something that sounds like that. What'd you say? Yeah, true. Really pretty small or pretty big. Both, I guess. Easy? This one reminds me of the grasshopper one because it's just wording. There's not really any numbers involved. You're just explaining it. Case 6. The table below shows the amount of money Rob earned for the first 9 weeks this year. What is the interquartile range for the amount of money that Rob earned for the first 9 weeks this year? Underline interquartile range. Interquartile range is IQR. First question for you. How do you find interquartile range? Cody? How do you find it, though? You're right, but what do we do, Amanda? Good. Upper quartile minus lower quartile. Interquartile range is range for a box and whisker plot. So now my question is, how do you solve this problem? Gray? What, easier. What did I have? I'm the one that always did this one with you guys when we did rotations. How did I have you do this? Yeah, calculator. So let's go to our calculator. Let's make a box and whisker plot on the calculator to find the upper quartile and the lower quartile so we can solve this. Okay, let's clear the memory on the calculator. Second plus 712, enter.